Java is an object-oriented programming language. The goal of this lecture is to introduce you to classes, objects, and methods, which are fundamental concepts in object-oriented programming. So why is the object-oriented approach good for problem solving? In our daily life, we often use tools or artifacts to help us in solving problems. We use stoves, ovens, toasters, and microwave ovens to make food. We don't have to understand how they work. What is important is to have a good recipe. A recipe, in a way, is like an algorithm. When we need to travel from one place to another, we use different transportation means. We could travel by land using cars, trains, or bicycles, or travel by air using airplanes and helicopters, or travel by sea using ships and boats. These are concrete or tangible objects. There are also non-tangible objects. If you want to access the internet using a mobile device, you can connect to the network using the cellular network of your phone company. You can also use Wi-Fi or connect to other devices using tethering. When you use your smartphone to communicate with others, you can open up the phone dialing pad, an email app, or a WhatsApp app. Each of these can be considered as a computational object or software object. From these examples, we can observe that people like to group objects with similar properties together and give them a collective name, such as oven, car, airplane, and phone. While they share similar behavior in terms of their usage, each of them also has some distinct properties. For example, while ovens can be used for preparing food, there could be electric or gas ovens. Cars are used for transportation, but each car may have different color and gas mileage. As for smartphones, I'm sure that the settings and content in my phone is different from yours. An object-oriented approach would be able to capture all these similarities and differences. Let's use car as an example to elaborate further the object-oriented concept. Here is a collection of cars. These all seem nice-looking cars that we all like to have. We know that a car is a kind of vehicle that shares certain properties, such as wheels, they have engine, and they need fuel to keep the engine running. And each car has an owner. They perform certain functions. For example, it can accelerate and slow down. It can back up and make turns. Hopefully it won't bump into others. Let's move it back to the original position. There is ownership for each individual instance of cars. This could be my car, although I may be too old for a car like that. And these are cars for Mary, John, Lily, and Tom, or some other names. And they all have distinct properties, such as color, number of passengers it can take, year of make, size of engine, etc. In object-oriented programming terminology, they can be considered as a class of cars. The instances of individual cars are objects, and the characteristics of these objects are the attributes or properties, such as color, year of make, size of engine, and so on. These are often called fields of objects. An object can also exhibit certain behaviors or actions that it can perform. For example, moving forward, moving backward, and making turn. These are called methods in object-oriented programs. Notice that there could also be hierarchies of cars. These are passenger cars. You could also have vans, trucks, and SUVs. Later in the course, I'll introduce the idea of subclass and superclass, where subclass could inherit the properties of superclass. But let's defer the discussion on that for now. So we can see that objects are fundamental building blocks in object-oriented programs. In object-oriented programs, software objects are used to model real-world objects, which exhibit certain states or attributes, and behaviors or actions. Let's now take a look at classes, objects, and methods in Java. We have seen that a class describes a group of objects with common properties and behaviors. For example, we can define a class of car that stands for the general concepts of vehicle that moves on wheels and can go from one place to another, or a class of smartphone. These are mobile electronic devices that can be used to make phone calls, surf the web, play music, send SMS, etc. We can use the keyword class to define a class in Java. Actually, we have used the keyword class before in our course grade program, and I have also mentioned before that all Java programs are classes. The The two statements here declare two classes, one for car and the other for smartphone. Notice that car and smartphone are Java identifiers. Upper camel case is often used as the naming convention for classes. The purpose of defining a class is to design a template for creating objects in that class. Once a class is defined, we can create instances of objects in that class. Object and instance are often used interchangeably. In the previous example, in a class of car, there could be different instances or objects of cars that belong to me, Mary, John, and others. In a smartphone class, a different instance can be created for each student in this course. Similarly, if a class of students is defined, instances of students can be created for representing each student in the class. So the class here can be referred to as the software class as well as the view class. In Java, instances of objects are created using constructors and the keyword new. I'll come back to these later in the lecture. As I mentioned, a class acts as a template or blueprint for an object. The definition of a class needs to capture two main characteristics: the state and properties of an object in the class, which is often referred to as a field. For a car object, the fields could include the name of its owner and its color or locations. For a smartphone, its brand and model, such as iPhone 5S or Samsung Galaxy S5. They could be stored in the objects fields. The second characteristic is an object's behavior. Objects exhibit their behavior through methods. Methods are operations that can be performed to change the object's state. For example, to change a car's position by moving forward or backward, or to put a smartphone to sleep mode, or to turn the volume up or down. Before discussing in detail how to define the fields and methods in Java, let's first take a look at a simple example on the different components that we just discussed.